So I have this app that I built running on top of Windows IoT Core, and it's basically using a Raspberry Pi device, which is right here at the bottom, and on top of that I have a FEZ hat shield that has a bunch of sensors like the thermometer right here, and then I have the ambient light sensor right here, and then I have two buttons and two LEDs right here. I'm using that to kind of display some telemetry information in my app, in my Universal Windows app, and you can see the light sensor change as I move my hand on the sensor. And then there is a temperature gauge, and then there is an accelerometer that changes as I move this device itself. So and then this is kind of like built on top of this is a demo code that was shown at the build conference. I kind of built on top of that another app that actually hooks up a motor and uses the PWM output of the Raspberry Pi, or the Shield actually, to control that motor and change the speed of the motor based on how much which one of the buttons on the hat or the shield are you pressing. So based on these buttons, I'm changing the speed of the motor. Now the motor is basically a 9 volts motor right here. So it's a 9 volts motor that's connected to a NPN transistor. The transistor acts as a switch and is connected via a 1 kilo ohm resistor to the PWM output of the shield that is hooked up on top of the Raspberry Pi 3. And then there is also a flyback diode that makes sure that the motor doesn't damage my Raspberry Pi in case there is a reverse current or something. And then I have the power that is a 9 volt battery, which is this battery right here. So I'm just using normal battery that I got for cheap. And then this is my circuit board that you saw up there. So this is my, let me zoom out a little bit. This is my motor right here, which has something like a fan that I've just built out of scrap. But then that's kind of connected to the flyback diode right here, and then across it, and then there is a NPN transistor, and then the base of the transistor, this is this yellow line, this yellow wire, is connected by a 1 kilo ohm resistor to my PWM output, pin number 12, PWM 12 of my Raspberry board, of my shield on top of the Raspberry board. So right here, I'm just gonna use a pointer. So so right here is the PWM 12 pin that I'm connecting to my base of my NPN transistor, and then the ground of my shield is connected to the ground here, and that's connected to the negative terminal of my battery, which is right here, this one here. So and the NPN transistor actually acts as a switch. So based on the current provided by the PWM output of the shield, if there's current there, then it's going to actually complete this circuit, and that's why you get the motor running. But then the PWM output is actually a pulse width modulator output, so you're gonna get like this spiking voltages or current running through this output here. So I'm gonna fix this real quick. Okay, and I'm gonna hook up the battery now to my power supply here, and I have the app running already, so you can see the app is running. And in my app, what I'm doing is, I'm gonna show that in a second. So let me connect this here.